How can I use the Pythagorean theorem? And its converse. To classify and solve triangle problems. How can I use the Pythagorean theorem and its converse to classify and solve triangle problems? All right, so the Pythagorean theorem, we're talking about right triangles, right? So let's say that if triangle ABC is a right triangle, with right angle C, then A squared plus B squared equals C squared. Done that a few times this year, right? Okay, you know that for every right triangle, the two shorter sides are your sides A and B. They're your legs. Your longest side is C. So for a right triangle, the two shorter sides, the sum of the squares, the two shorter sides are equal to the hypotenuse squared, or the longest side squared. Okay? So the other thing you need to know for today, so let's write this down. If A squared plus B squared is equal to C squared, then it's a right triangle, isn't it? All right, so that's kind of the converse of the Pythagorean theorem. Pythagorean theorem says for every right triangle, A squared plus B squared equals C squared. Well, if we flip the hypothesis in the conclusion, you can say that if A squared plus B squared equals C squared, then the triangle is a right triangle. So you're going to get asked questions today of, given three side lengths, is the triangle a right triangle? So take the two shorter sides, square them, add them together, and see if they equal the longest side squared. If they do, it's a right triangle. If A squared plus B squared is greater than C squared, if A squared plus B squared is greater than C squared, then you've got an acute triangle. The two shorter sides squared and added together, if that's greater than the largest side squared, then you got an acute triangle. And if a squared plus b squared is less than c squared, then you got an obtuse triangle. That's the air conditioner. So if you get a question like, given the side lengths, eight, 6, and 11, classify the triangle as right, acute, or obtuse. Well, you got 8, 6, and 11. First of all, does it form a triangle? Quick review there. Does it form a triangle? Do the two smaller sides add up to more than the third side? So you do have a triangle. Because I think they slide that into your assignment today. They might give you a problem. It's not even a triangle at all. Okay, so make sure it's a triangle first. Two shorter sides have to add up to more than the third side. So now, you got 6 squared plus 8 squared, and you're trying to see how that relates to 11 squared. So put a box there if you want. So you got 36 plus 64, and how does it relate to 121? All right. 36 plus 64 is 100, isn't it? Okay, so this is 100, and how does it relate to the 121? It's less than the 121, isn't it? So if it's less than the 121, what do we say it was? All right, it's an obtuse triangle. That's all there is to it. Okay? Yeah, it's a triangle, but it's not a right triangle. It's an obtuse triangle. And then the rest of the assignment today, you're just going to be finding the missing side using the Pythagorean Theorem. One other definition you're going to want to have in your notes, write this down. A Pythagorean triple. A Pythagorean triple is a set of 3 non-zero whole numbers A, B, and C such that A squared plus B squared equals C squared. Basically a set of whole numbers that forms a right triangle. All right, the most common set or Pythagorean triple is 3, 4, 5. 3 squared plus 4 squared equals 5 squared. And in your book on page 548, if you want it for your notes, there's a table, common Pythagorean triples. And it lists a bunch of them. And you can see that there's a pattern there. Okay? 3 times the number, 4 times the number, and 5 times the number. Form a Pythagorean triple. Or basically 3 numbers that are in the extended ratio of 3 to 4 to 5. Okay? Another one is a set of numbers in the extended ratio of 5 to 12 to 13. Any questions?